Hello, everyone. My name is Kristen Bridgers. I am the marketing manager here at Trafficware, and we want to welcome you today to understanding adaptive signal control technology, our product SynchroGreen. I'll be moderating the webinar, so all that means for you all is that I'll be fielding any questions that you might have for our presenter, Matt Cooper. Making sure he gets them in a timely manner as he's presenting to you. So Matt Cooper is the Business Development Manager of Adaptive Systems for the East Coast here at Trafficware. If you have questions for Matt during the webinar, please use the Q&A window to type them. You can find the Q&A window by navigating to the bottom of your screen and pushing Q&A. It'll pop up in a window for you and you can type your question there. We'll have Matt answer those aloud, and we'll also type the answer to the question as they arise. A couple of other items before we jump into our webinar today. We will be sending up a follow-up email to this with helpful links and resources for you. So if you aren't able to gather everything today, we will send a follow-up email to all of our attendees. Also, if you're interested in additional upcoming webinars, please follow us on social media at Trafficware on Facebook, LinkedIn, and Twitter. So without further ado, Matt, take it away.
Thank you very much, Kristen, and good afternoon, everyone. Thank you for joining us today for this SynchroGreen webinar. I hope that everyone has been able to stay safe and healthy thus far, and we are all adapting to this new world of working from home. I was just introduced to one of the latest and greatest challenges, which was not a dog. There are no big dogs in the neighborhood, not the trash man coming around collecting the trash, but right when I got set up for this webinar, the neighbor decided to start mowing the lawn. So we have changed locations. We are in another part of the house, but we are secure from the sound. So without further ado, let's dive right in. In terms of our objective for this afternoon, we're going to look to provide you guys with a fundamental understanding of how SynchroGreen operates, what it does, how it works, and what the benefits are for using it, as well as give you some information regarding what types of spots you should look for if you're considering whether or not you should be doing a deployment around your network. As Kristen mentioned, if you have any questions, please use the questions button or the chat button in the webinar tool, and there will also be some follow-ups sent out with some more helpful information. And that's my contact information there if you would like to reach out directly. Our agenda for today, first we'll start with an overview of adaptive traffic signaling technology in general, what it is, how it's beneficial. Then we'll go into SynchroGreen's background and its optimization approach. So what is it about SynchroGreen that makes it unique in the market? And how does its optimization approach provide you guys with solid benefits? Then we'll talk a little bit about analyzing outcomes, so things to watch out for and some of the tools that are available for considering measurements on your network regarding the results. And then we'll close it out with a bit of a Q&A session. As Kristen mentioned, though, if you have questions along the way, please feel free to drop them in the chat. For our overview of adaptive traffic signaling technology, what does an adaptive control system do? First and foremost, an adaptive system adjusts your signal timings based on surges of traffic. So what you really want to look for is it to replace time of day coordination in areas that have unpredictable traffic. From there, you'll see decreases in travel time, delay, congestion, and emissions, along with improved safety. Now, that's a bit of a mouthful. If I was going to distill that down into pretty much one overarching example that can really hit home in terms of the value that adaptive provides, the way that I would sum it up is this, with a sports analogy. Baseball, if you consider a baseball game, usually baseball games, MLB, when they're active, start at around 7 p.m. So you can build up a time of day plan that says, okay, this game's starting at 7, so from about 5:30 p.m. to around 7:15-ish, we're going to see a lot of traffic flowing into the area from folks who are looking to attend the game. And your time of day plan can accommodate those volumes. In normal circumstances, that game's going to go about 2.5 to 3 hours, so around 10 o'clock, 10:30. You can switch to other plan or have it timed to set up, and then you can accommodate the volumes from people who are leaving the stadium, leaving the city in general, heading back home after the ball game. Hopefully the home team won. But what if things go a little bit differently from that? What if you have one of those ball games where, like a few years ago, I'm from Baltimore, and over at Camden Yards, we had a game where it was Baltimore versus the Red Sox, and that game went 19 innings. Now, if a 7-inning game, or 9-inning game, sorry, goes about 2.5, 3 hours, you can only imagine how long a 19-inning game was. In this particular one, we wound up having one of our first basemen pitching at the end of the show. Fortunately, he had a pretty mean curveball and got a couple strikeouts, but when it was all said and done, that game didn't end until well after midnight. So right when that time of day plan for folks who were leaving the stadium was going back to normal operations, that's when you were seeing the surge in traffic. So if you weren't using adaptive, what would you see? You would have had a time of day plan accommodating massive volumes with no volumes there. And then once it reverted back to normal operations, you would have seen a time of day plan accommodating normal operations with massive volumes, the exact opposite of what would have been beneficial for the network. So what you can do with adaptive is, to extend the metaphor a bit, have it be those extra eyes and ears out there on the field, monitoring the detection, monitoring the conditions, what's going on out there, and responding appropriately. So adaptive is an ITS tool that, when deployed properly, can be very effective. But one important thing to take away is that it's not something that is a mystical solution that you set it and forget it. You can't deploy and walk away from adaptive and just expect congestion to magically disappear forever. It is those extra eyes and ears out in the field, but there are certain tweaks that can be made to get it to operate as best as possible in your particular network's conditions. Those are the things and the parameters that, when you work with the adaptive tool, adaptive solution, it can deliver positive results for you. So while it's not set it and forget it, it's also not something that's overbearing, but if you work in conjunction with it, if you leverage it, you can get some really good results. All things considered, why are some agencies or companies debating whether or not they want to use adaptive traffic signaling? These are some of the things that we've heard in our conversations with both current customers and new prospective customers in terms of the things that are potentially giving them pause. First one is compatibility with existing infrastructure. The maintenance load for our maintenance engineers that are out there in the field is already big enough. And so what you don't want to do is deploy a system that is going to overload them in terms of having to introduce additional hardware, having to overcomplicate the software, and having to completely change your detection regime in order to accommodate an adaptive deployment. You want something that's going to work in conjunction with what's already out there, or at least as minimally invasive as possible in order to deliver good results. From there, you've then got the perceived complexity to deploy and maintain that system. Again, sticking with that maintenance regime or that maintenance perspective, if you have to then completely retrain everybody on working with new controllers, working with new packages, working with new programs, suddenly you can start to think that maybe the cons outweigh the pros, or the benefits are outweighed by the costs in terms of what you'll have to do in order to get it deployed in the first place. Continuing along that same vein, there's also potentially some difficulty in learning and using the system. This is more thinking about the software side of things. So in your TMC, you have staff who are used to working with certain types of interfaces already. If you're then overlaying an adaptive system, it's a completely new window that they have to deal with, completely new package that they have to deal with. If it's too much, then suddenly you might see them not using it at all. And that's kind of where that set it and forget it mentality sometimes comes up. Folks aren't necessarily as keen on having to completely retrain, and folks aren't necessarily as keen on investing additional time if they're not really sold on the benefits too much. From here, you can also start to think about potential restrictions on multimodal tactics. Depending on what type of approach you take for deploying the adaptive, and we'll talk a bit more about this later, you can sometimes put yourself in a position where, instead of having the adaptive work in conjunction with everything that's already out there, the adaptive then clashes with things like the pedestrian extensions. It clashes with things like the flashing yellow arrows, or multimodal considerations, connected vehicles, so on and so forth. And when you have adaptive clashing with those things, suddenly the value proposition starts to erode. And then finally, some folks wonder whether adaptive is too expensive in and of itself. But what I always say to that one is, if you're following the FHWA guidelines and you are updating your timing plans every year and a half, every 2 years at the latest, this is depending on which version of the guidebook you're reading, well, by the time you've updated those timing plans 2 times, you've already paid for adaptive along the corridor. Now, what's the key difference? After you update those timing plans 2 times, what then has to happen? In a couple years' time, to keep pace with the guidelines, you then have to update those timing plans again. So suddenly, going the updating timing plans route is costing you more than having deployed adaptive, because after those 2 years pass, after that second lot, so after 4 years pass, you still have adaptive up and running. The difference is that adaptive is still learning. It's still optimizing based on what the conditions are at that point in time. So it's still providing value from that initial investment. Whereas with those timing plans, if you're not staying on top of them, we all know how they go. They start to fade. Their performance starts to deteriorate. And that's why they come back and they get updated time and time again. So instead of having to make that recurring investment in terms of upkeep on those timing plans, if you're able to deploy adaptive, it'll keep working on your behalf long after that initial investment has been made. So again, folks think about the compatibility with the existing infrastructure, whether it works with what's already out there, or at least comes in a kind of a seamless way. They think about the perceived complexity to deploy and maintain it. So how much extra work are they creating for the maintenance engineers? How much extra work are they creating on the procurement side as well? Then you've got difficulty in learning and using the system. So if we're going to use this software package, is it going to be overly complex? Is it going to have a whole bunch of things that we have to consider in order for us to even start to get some good results? You've got the potential restrictions on multimodal tactics or controller level activities. And then finally, you've got the cost. So in taking all those things into account, we believe that the approach that we're taking with SynchroGreen is one that provides value on all those different fronts. Now, we'll talk a bit more about SynchroGreen's background specifically, along with its optimization approach. So what is it about SynchroGreen's approach that makes it different and provides value over and above some of the other systems that you'll see out there? First and foremost, SynchroGreen is a module within Trafficware's ATMS platform. What that means is that in order to deploy SynchroGreen, we actually have to deploy our ATMS platform, which is a good thing. Along with SynchroGreen, you have the option of getting access to all the different models that you see here, be it signal performance measures, connected vehicle, emergency response, transit signal priority, so on and so forth. SynchroGreen is therefore one tool in the entire tool bag that is able to work seamlessly in conjunction with everything else that you see there, as opposed to having SynchroGreen sit outside of it, sit separate from it, and then therefore clash with all these different other applications. SynchroGreen is built for transportation networks. We're a software-based system that runs on the traffic controller. We have a bit more information about this a couple slides down, but what that means is that rather than having to install additional hardware in your cabinet, you can work with the controller that's already out there. If you're an existing Trafficware customer and you're on one of our latest software versions, odds are you already have SynchroGreen there on that controller. If not, there's an upgrade process for putting the right software package on there. Our system is deployed and supported by experienced field application engineers. We've got folks who have worked on the government side and then transitioned over to private sector, joining our team. And we've got folks who've been with us for over 20 years. They know about deploying these systems. They're very familiar with the varying conditions that a traffic network can see. So when you call and you say, hey, I'm not really too familiar with this, how do you respond to it? They can give you not only feedback and suggestions, but they can give you case studies. They can give you stories of where they saw something like that, unless it's something completely novel, of course. But they can give you insight based on their actual field experience as opposed to just working in theory. SynchroGreen, as I've said multiple times now, operates in conjunction with multimodal and pedestrian measures. Instead of clashing, they work in concert. And then SynchroGreen is the only system that's seamlessly compatible with Synchro and SimTraffic for adaptive modeling and simulation. Why is this important? We'll talk about analyzing outcomes in section 3 of this presentation. But before you get to the stage of analyzing outcomes, you also want to walk into it with a sense of what you can potentially expect in terms of the gains that you would see from deploying adaptive. One option available is that we have certain consulting partners, as well as a team on staff on our side, that are able to use Synchro to do adaptive modeling. So they can take a corridor where you have existing Synchro database, existing Synchro files, I should say, for that particular set of intersections. You can send those to us, and we'll say, okay, so these were the traffic volumes, these were the results that you saw over such and such a window. What would happen if you would have run adaptive instead of what you had in place at that point in time? And they can give you an apples to apples comparison of what the results would have been with adaptive as opposed to what the results actually were. So if you're considering whether one spot is good for adaptive in general, if you're weighing up the pros and cons of multiple corridors and trying to find out which one would be the best investment for you, you can use these adaptive models to then get some projections and say, all right, you know what? We're seeing the types of gains that we're looking for on this particular corridor for the conditions that it's facing. And we think that this is where SynchroGreen Adaptive should be deployed. Now that modeling isn't suited for other adaptive systems. It only works in conjunction with the SynchroGreen system. So we can't model a competitor's adaptive system, but we can at least give you an idea of how SynchroGreen would perform in those circumstances. And that way you can use that information for conversations with management or business case, things of that nature. And here we are, software-based solution. Again, SynchroGreen resides in your current controller, so there's no black box required. That means there's no additional proprietary hardware and no additional points of failure. We talked about that maintenance perspective earlier. We don't want to overcomplicate things for the maintenance guys, and we also don't want to make their job more difficult by introducing additional points of failure. So you're also able to save valuable space in your cabinet, and we have NTCP-based local controller software. Right here, we're referencing Scout or Patriot version 76, but in the field, we've also seen SynchroGreen running on versions as far back as .61. That means something for our current customers. New folks, not necessarily, but we've been around for quite some time, so we have a lot of different software versions that are out there in the field running successfully. I talked a little bit earlier about what happens when you take a software-based approach and what can potentially happen when you take a hardware-based approach. By hardware-based approach, what I'm talking about is this. If you think about your cabinet as a software stack, when you take a software-based approach, the software stack looks like this. You have your controller at the top, you have your detection and other inputs feeding into the controller, you have other things that are feeding in at those levels as well, but the controller is at the heart. The controller is at the top. That means that it is the controller that is in charge of that intersection. So if you have transit signal priority operating, that's happening through the controller. If you have connected vehicles data is based on what the controller sees. So if the controller knows what the light is right now, what it's going to be, it can send that out. If it knows what the underlying detection is seeing, it can send that out. And that's valuable information that third-party applications tend to use. When you take a hardware-based approach, the software stack in the cabinet looks like this. You have the cabinet processor at the top, then you have the traffic controller, and then you also have the detection. But instead of the detection feeding into the controller, the detection feeds into the cabinet processor. Why is that important? It's important because when the detection feeds into the cabinet processor, the controller is then only receiving calls from the cabinet processor. So the controller doesn't know why it's doing what it's doing. It only knows that it's being told to do this, and so that's what it does. When you think about connected vehicles, if you don't have that underlying information, you're not really able to provide value to the folks who are consuming that data. Now, there are certainly ways around this. You can have a connected vehicles module through the separate adaptive application, and you can have a connected vehicles module through your ATMS platform. So you can imagine how the conversation will go with Google when they say, hey, we want to partner with your city. How do we get your data? All right, you'll go here for this set of information. Let's say you have 10% of your signals on adaptive. You go here for the adaptive signals, and you go here for the others. They're going to look at you, and they'll say, okay, you can go there to get that and there to get that, and you send us a combined feed. We're not going to go to multiple points. That's going to be a difficult conversation. However, when you take the software-based approach, you're able to get everything from one spot and then publish information from there. If you think about flashing yellows, as I mentioned before, flashing yellows are a controller level activity. Cabinet processors for adaptive aren't built to process flashing yellows. So if you have a cabinet processor in place, you cut off that capability. If you think about the transit signal priority or emergency vehicle response, again, those are controller level interventions. You can kind of try and work some magic, but what we've heard from customers in terms of what they see happening out in the field is that the hardware-based approach provides more limitations than it does provide benefits in terms of what they see when they try and do adaptive and use these complementary technologies. Therefore, they're considering moving over to us, or in many cases they have moved over to us from a hardware-based approach, that software-based solution instead, to meet those needs. I see that we have a question.
Yes. Darren Greer is asking, is the video supposed to be changing? The slide, I think he means. Darren, sometimes if you have a low speed for your internet connection, it may have a lag on it. Possibly give it a moment. But Matt, maybe you could let him know what he should be seeing on his slide.
Okay, so right now you should have a cabinet on the slide with software-based solution on the screen.
Perfect. Thank you, Matt. Please continue.
No problem. I do tend to linger on a bit, so sorry if I caused some concern. But Darren, do let us know if it's still stuck. I'm changing slides now. Okay, now we're on communications approach. In order for any adaptive system to be successful, there are two critical elements. Number one is the communications approach, which we'll talk about now. And number two is the detection, which we'll talk about in a moment. From that communications perspective, we'll work with a lot of different technologies that are out there. So we'll work with fiber, we'll work with wireless, and we'll work with cellular as well. So what that means is if you have fiber deployed across your network, that's awesome. And we're more than capable of working with that. However, if you are like a lot of municipalities, organizations out there, and you haven't quite gotten to a fiber deployment everywhere just yet, we can still work with you because you're able to build up communications via the cellular modems. And fortunately, we haven't seen any issues in terms of latency. Now, if you put out a cellular modem in a remote location that has bad signal, that's not going to be as successful as we would like, but we walk into that eyes wide open. So we'll require good communications. As long as they're consistent and reliable, then we can work with it. We're an Ethernet-based system, and in terms of fail-safes, should communications drop out, two things happen. First, there are multiple retries. So just because there's a bit of a lapse doesn't mean we suddenly turn off adaptive for the corridor. We'll give it a couple shots. However, If the communications lapse is consistent and extended, then what happens is a time of day fallback by default. What does this look like? On a 5 intersection corridor, let's say that number 3 is the intersection that drops out. By default, that corridor will revert to its base time of day plan. So SynchroGreen starts with the time of day plan and it adjusts up or down from there. We'll talk about that in a few minutes. But this corridor will fall back to time of day for the entire corridor if communication drops out at intersection number 3, or any of the intersections for that matter. We have that set as a default because in practice, when given the option, most of our customers elect to have that be the default position. They'll just revert back to time of day until communications are restored. However, you do have some flexibility there. What you can do instead is you can have it revert to time of day for intersections 1 to 3, and then you can have it remain on adaptive for intersections 4 and 5. And this is, again, taking a look at the spacing of your particular set of intersections, the conditions on your network, and optimizing the system to see what works best given those conditions. You can also take the other approach. You can take intersections 1 and 2, have those be on adaptive, and you can have 3 to 5 be on time of day instead. In practice, what we typically see is the entire corridor just reverting back to time of day until communications have been restored, but you do have the option to have it play out in those couple of different ways. If you think about longer corridors, let's say 10 intersections, intersection number 2 drops out, and you can have 1 and 2 be on time of day, and 3 to 10 be on adaptive. It's completely up to you. So you might want to play it a certain way for some intersections or some corridors, and then play it differently for others. Now, what you'll want to do to start off with is have good communications and make sure that they get restored as quickly as possible. But in the event that these things happen, and they do, no getting around that, you do have options in terms of how you respond to it. Okay, moving on. System topology, so how the system is put together. SynchroGreen is a centralized system, and it also operates locally at the intersection. So what that means is that at the back office, where ATMS is deployed, you also have the SynchroGreen central server. In most cases, we're able to see SynchroGreen and the ATMS platform live on that same server because there's more than enough space for it. And then you also have SynchroGreen running on the local intersections. So on a cycle-by-cycle basis, because we're a real-time adaptive system, the controllers are sending information regarding the detection results that they're seeing, and then they send that back to the central server. The central server runs its calculations and says, okay, these are the conditions that we're seeing. This is the timing plan that we think will best meet the need. It pushes that back out to the controller, and the controller then responds accordingly. But as we were talking about that software stack earlier, the controller is what's ultimately in charge. So the SynchroGreen central server is sending out the suggested timing plan, but if it then receives information that, hey, we've had a new PET activation that comes up, the controller then responds to that PET activation. So the time gets shrinked a little bit, but it's still working off of that timing plan that was sent out. There's a feedback loop that happens every single cycle here. So now the SynchroGreen central server then receives information regarding that new PET call, and it automatically builds in that pedestrian call. So it's factoring it in, building it into the timing plan, and then delivering the optimized results for that next set of conditions. And this is happening on a cycle-by-cycle basis.
Matt, we have a question from Don McGowan. How about a cabinet knockdown, he asks.
Cabinet knockdown would function the same way as the communications loss because there's nothing coming from that cabinet at that point in time. That one would be a bit of an extended stay for the time of day plan. So if it's happening at intersection number 1, you could feel comfortable having 2 through 5 operating on time of day until that one gets restored. If it's happening at number 3, you might want to take a look at that and say, you know what, we'll just have the whole corridor run on time of day until things get restored. You do have the options there, but it treats it like a communications loss.
Perfect. Thanks,
Thank you for the question, Don. In terms of detection, we can work with any detection technology that's out there aside from one type of technology, and that is the proprietary detection technology that has been built up for the InSync system. Why is that the case? So we work with inductive loops, we work with standard video systems, we work with magnetometers, so our pods, and then we also work with radar. The reason why we are unable to work with InSync's proprietary detection is that InSync's proprietary detection does not capture all the values that we need in order to populate our models. As a result, we can't run off of that because it's not sending all the information that we need. And vice versa, there are things that InSync system is collecting that we don't need for our system. So for customers who have deployed InSync in the past, when they have moved over to our system instead, unfortunately, that has meant that they have been required to replace that set of detection with new detection out there. However, for customers who have used any other type of detection, we're able to come in and plug and play, work with what they have there, with a couple caveats. First, we require detection at the stop bar and then advanced detection as well. At the stop bar, it needs to be lane by lane, so we're usually seeing a 6x6 out there. For a video system, that would mean just adjusting the zones. For loops, that means adjusting the channels. So again, we can work with what's already out there, just adjusting the parameters, or the configuration, I should say. And then in terms of the advanced detection, as long as you're following FHWA guidelines, which at last check should have been 340 feet, I believe, we require a minimum of 250 feet back and a maximum of 500 feet back. If you have intersections that are spaced out less than 1,000 feet, you don't have to have advanced detection, and our deployment down in Boca Raton does feature that type of setup. But by and large, intersections are more spaced out than that, so you would need to have advanced deployed there. But again, the good news here is that from the maintenance perspective, we can work with whatever detection technology is already out there. And there are easy ways in terms of, if you already have stop bar, you can use certain technologies to augment that deployment without having to incur significant costs and take a lot of time in order to get the detection set up. And that's something we can talk about on an application by application basis, just depending on what the characteristics of the corridor are and the setup for those particular intersections. But again, the good news is that pretty much any technology out there from a detection perspective, we can work with. And one of the questions we often get, because I talked about connected vehicles earlier, in terms of the connected vehicles information, while we haven't seen a deployment with connected vehicles data just yet, it is something that is on our radar. We see it coming, and we're looking forward to when there is an install base, or a user base really, that is strong enough and large enough to accommodate using that type of information for detection technology. If you would have mentioned that a few years ago, nobody would have known what you're talking about, but we're not too far off from that potentially being a capability. Getting into the core of the presentation, half an hour into it, basics of the SynchroGreen system's operations. First and foremost, as I said before, it's a real-time adaptive control system. What does that mean? That means that on a cycle-by-cycle basis, SynchroGreen is receiving information from the controllers and making adjustments in order to optimize the traffic flows for what is currently happening there on the network. How does this differ from some other potential approaches? Well, there are a couple of different ways to look at this. One is that you have some adaptive systems per se that take a more of a traffic responsive-ish type of approach, meaning that they will aggregate information for 5, 10, 15-minute windows and say, okay, over the past 5 minutes, we'll just keep it at the short end. Over the past 5 minutes, these are the conditions that we've seen. So now this is a timing plan that we think will most effectively meet those needs for the next 5 minutes. But what do we all know to be true? The volumes can vary, sometimes pretty significantly, from cycle to cycle. We have a flood of questions coming in, so let me just take a look at that.
Yeah, Matt. So the first question is from Don again. He's asking, is downstream detection helpful?
There are indeed ways to use downstream detection, and that's why we talk about the application by application review. So if there are, it sounds like there are particular corridors that you have in mind. So let's set up a time to talk about those specific applications one-on-one or in a separate session. And we can start to look at what would be most effective in those areas. And then there was another question.
Yeah, Matt, I'll give Don your contact information directly here. We have another question from Joe. With the new SynchroGreen technology and new ATC controllers, is it required for advanced detection?
Yes, so the SynchroGreen and ATC controllers, it still requires the advanced detection to be in place. I saw there was another question that came through regarding diamond interchange. So given that we only have a limited amount of time on the phone call, what it'd be best to do is just talk about specific applications in a separate session. More than happy to follow right back up on it immediately, but we have a fair bit of material to cover here. So if it's okay, we'd like to table that one and then have a separate discussion about it.
Sure. I'll let Mr. Betty know your contact information directly so that he can set up a time to communicate that with you.
Okay, thank you. And that is something that we've done before. I actually just explained that concept to someone not too long ago. So I have a set of information I can forward right over to you.
Perfect.
So we were talking about the real-time difference as opposed to some other potential methods. So if you take more of a traffic responsive-ish type of approach, what then happens is that you're basing your adaptive timing plan, which is supposed to optimize for the conditions that are currently out there. You're basing that adaptive timing plan on the previous 5 minutes, and you're using it to accommodate the next 5 minutes. So you're never quite getting a match. What that means is that you're either going to be over or under what the optimal approach would have been. So you're leaving capacity out there or you're underutilizing capacity. If you're going to take an adaptive approach, if you're going to make the investment for adaptive, you want to have a system that gets you exactly what you need every single cycle out there. Otherwise, what's the point? So we're adjusting signal timing based on current traffic conditions, and those unpredictable conditions can often be caused by schools, event centers, retail, accidents, if there are unfortunately certain spots that might be more prone to fender benders or things of that nature. Adaptive is there to, again, like I said earlier, be that extra set of eyes and ears in the field to accommodate what's happening out there. And it does it again on a real-time basis. And also, just as importantly, we utilize national standards. So it's the NTCIP-based software interface, and we also follow NEMA signal phasing. While that would seem like common sense, it's important to call out because there are potentially systems out there that don't follow the NEMA signal phasing. So if there's a movement that doesn't have any need to be served, it jumps right over it. What then happens is that violates the driver expectations. When you violate driver expectations, when you skip something that they were expecting, you're then having them or causing them to have to think. Take a moment, pause, and think about what's happening there on the network. The more times we ask folks to think and interact with things that are out of the ordinary, the more decisions they make. And while we all think that we are the best drivers in the world, the more chances or the more opportunities we have to think, it's the more opportunities that we have to potentially make a mistake. So we we do adhere to the NEMA signal phasing so that we don't introduce any additional complexity and violate those driver expectations out there in the field. There's enough for drivers to have to consider under normal circumstances. We don't want an adaptive solution that then causes them to have to consider extra things or out of the ordinary things. Talking a bit more about SynchroGreen's optimization approach. So every single cycle, we're looking at the cycle length, the split, and then the offsets. And the reason why we do this is to smooth the sawtooth effect. If you think about time of day plans at a high level when they get deployed, let's say you have your time of day plan from 7:30 a.m. until 9:30 a.m. to accommodate the morning peak. Then you get back to normal operations. You might have it adjust for lunch. get back to normal operations, and you might have it adjust for the PM peak. So what's happening is it's at one level, then it jumps back up. Then it goes back down, then it jumps back up. Then it goes back down, then it jumps back up. And it has these sharp cliffs. In reality, the volumes don't just go from 0 to 100, 100 to 0. They slowly taper off as less and less people are out there in the network. They reach their destinations or they turn off, what have you. And so SynchroGreen is able on a cycle-by-cycle basis to smooth that sawtooth effect. So you don't have these peaks and you just drop off immediately. It smooths it out in accordance with the actual volumes that we're seeing out there. Now, when it's doing that, again, starting with the base time of day plan, I talked earlier about having to work with the system and get it to provide the best results for your particular network. There are a couple of different thresholds that you can set for SynchroGreen in terms of how it's operating. The first one is the minimum and maximum cycle length. Let's say that your base time of day plan for an AM peak calls for a 180-second max. If SynchroGreen sees that there is some very significant congestion, it can then jump all the way up to a maximum of 255 seconds. Now, you might say that 255 seconds is really long, and you've got some folks on a particular side street who don't want to wait that long. What you can do is you can set the maximum cycle length that SynchroGreen can extend to. So if you don't want it to jump all the way to 255, if you just want it to get to 210, you can say, okay, we'll cap it there. Even though you think that you need to go much higher, we're going to cap you at that 210 because of other conditions or other circumstances that we're aware of in our network. And that's how you're able to get the system optimized for working best in your particular network. Then you can also set how quickly those cycle lengths can increase. So sticking with that same example, if you're at 180 and SynchroGreen says you need to get to 210, you may not feel comfortable with it going from 180 to 210 in one cycle. What you can do instead is you can have it metered, or you can set the rate at which the step increases. So you can go from 180 to 190, 190 to 200, 200 to 210 over the course of 3 cycles. So instead of going from 180 to 210 in one fell swoop, you can stage it. That way the network, number one, has some chance to get used to that happening, but then number two, it also says, okay, well, you know what, if our detection is not necessarily as reliable as we thought, or we sometimes see some false positives, we can have it staged like that or metered in terms of how it's increasing to just make sure if SynchroGreen's calling for it, it really does need it. And if at each cycle, SynchroGreen's still saying we need 210, each time it ramps back up. Also important to note is that the master intersection adjusts dynamically. We mentioned a 5 intersection corridor earlier in terms of the communications example. If we stick with that, so let's say that intersection number 3 is the critical intersection to start off with. So intersection number 3 is critical, but you know what, something's happening at intersection number 1, and it's calling for a longer cycle length. For that particular cycle, intersection number 1 becomes the master. After the congestion or conditions at intersection number 1 have been alleviated, you can either go back to number 3, or if there's another one that is saying that, you know what, I need a longer cycle length, the dynamic adjustment can then see the master intersection be a different one. So it's always actively responding to whatever it sees out there in the network. And then finally, you can set SynchroGreen to optimize for single corridors or grid networks. So if you're in a CBD environment where you have a couple corridors that are going north-south and a couple corridors that are going east-west and they cross, during an AM or PM peak or whenever you deem necessary, you can actually have the cycle length be set to sync up for all those different intersections, for all those different corridors, so that they operate in unison. So these are some of the ways that within SynchroGreen, you can tweak the system and work with the system to provide the best results for your specific network's configuration and what you typically see out there. And that's what I was talking about when I said that if you work with the system, you'll get great results, but it's not necessarily a set it and forget it. Any of those scenarios that I talked about just now, they aren't necessarily do or die scenarios. They're things that most folks would probably live with, going whatever way SynchroGreen recommends, but they're things that you can watch out for to just get that extra level of benefit or that extra level of customization for your particular setup. In terms of how the cycle and split optimization process works, at the core of SynchroGreen's analysis is green utilization, which is the duration of time the green interval is effectively utilized. You want to see as many people arriving on green and progressing through the intersection on green. Well, they're not going to progress any other time unless it's illegal, but anyway, arriving to the intersection on green as possible. From there, you go to the target phase allocation, which is the amount of time each phase should receive under ideal circumstances. Then, number 3, SynchroGreen is analyzing the system globally and selecting the critical intersection and the calculated period duration, so that cycle length. And then finally, it closes out with proportioning the phase allocation based on the targets and assigning the critical period duration to all the intersections in the system. So it's looking for what that critical intersection is. It's looking for what that max period is. It's looking at what the current conditions are. It's looking at what the green utilization was last time around. And it's optimizing, taking all those things into account. But you see that arrow at the top from number 4 back to number 1, because it's a feedback loop. The controllers send back what actually happened. So SynchroGreen knows what it sent, it knows what actually happened, and it's able to take into account the next round of feedback and adjust accordingly. Offset optimization is the reason why we have the advanced detection requirement. If we don't have the advanced detection, we can't work with the offsets. But with the offset optimization, we're able to adjust for queues. We're also able to adjust for trends in early or late arrivals. One of the questions that comes up sometimes is if we have a corridor that is technically 10 intersections long, but we only want adaptive on intersections 2 through 9. So if intersection number 1 suddenly seems like it's sending a lot of volume to intersection number 2, which is the first adaptive intersection, intersection number 2, because it's on SynchroGreen, can have a look at what's happening and then adjust for those early arrivals. And vice versa, if intersection number 9 is seeing that folks are arriving later than normal, it can then adjust for those late arrivals.
Matt, we do have a couple of questions coming in. If a rail is running beside and across, is the ideal corridor?
So SynchroGreen does work very well in conjunction with transit signal priority. And then what you then have happening is SynchroGreen is analyzing what conditions it currently sees, so what it has to work with, and it receives the transit signal priority call and then knows that it has to meter out based on that limitation. And it's able to do this without having any delays caused by those transitions or anything of that nature. So that is a good use case for it.
Alrighty, and one more. In the example scenario, if an intersection requires a higher cycle length set to a max limit, will SynchroGreen adjust the cycle length splits and offset the other 4 intersections and ensure the green band progression for each cycle, or is there a transition period for these adjustments?
No transition period is necessary. SynchroGreen has everything staying in step.
Perfect.
So moving right through, we've got a couple slides, a few slides left. First is this one, strategy, the Trafficware algorithm. So while I'm not privy to the inner workings of the algorithm, I do know that there are 3 modes that our users can have established for working with SynchroGreen: balance mode, progression mode, and critical movement mode. In balance mode, SynchroGreen is taking a look at the current conditions. It's also looking at some historical results, and it's prioritizing it's not prioritizing the main line per se. It's looking at the entire system, so the main line and the side streets, and it's apportioning the time based on what the algorithm suggests by default. With progression mode, you are then able to prioritize the main line's progression through the network. So if you are at the PM peak or the AM peak, you can go into progression mode and have SynchroGreen prioritize that main throughway traffic to get them from point A to point B or wherever as quickly as possible. And that then happens at the expense of the side streets. This third one, critical movement mode. The best way to describe critical movement mode is in Lake Charles, Louisiana, even though they don't have that many intersections to begin with because they're a very small town, in terms of the number of intersections that they have on SynchroGreen compared to their total intersection count, they're actually one of our highest volume users of adaptive. The reason why is that though they're a small town, they're a factory town. So at a whole bunch of different spots throughout their network, they have these factories. Given that they're down in Louisiana, they're sometimes subject to some pretty volatile weather, and they can get a situation called a rainout. A rainout is where, you have to go with me here on this one, a rainout is where it rains so much that the factory closes down. That's pretty self-explanatory. So when that happens, you suddenly have 2,000, 3,000, 4,000 people all lining up to turn left coming out of the factory. That can be a pretty extensive wait time. So what they're able to do then is put SynchroGreen on critical movement mode, prioritize that left turn out of the factory, and get those folks out of that situation as quickly as possible. And it's doing this at the expense of the other side streets, at the expense of the main line, because it's prioritizing just that particular movement. Now with critical movement mode or progression mode, we'll normally see those set for specific windows. So critical movement for, let's say, 30 minutes, and then you come back and check it. What you don't want to do is set critical movement mode for an indefinite amount of time, because if you forget to come back and check it, you're sitting there prioritizing a left-hand turn, and there's nobody there turning left. So most times, we'll just see all of our customers using balance mode, but we do see progression mode on occasion. And there are specific applications where critical movement mode can be a real asset. Another application would be on a freeway perspective. If there is a set of intersections that are right by a freeway and there is significant congestion on the freeway and there's a backup or a queue that's been created at one of the off-ramps, SynchroGreen can be set to have a trigger. Since it's part of the ATCS platform, it can be set to have a trigger and say, look, when we see that the traffic has backed up to this point, that's a really long queue. And that means that pretty soon the congestion is going to start backing up onto the motorway instead of just on the off-ramp portion. So we can then go into critical movement mode to have the exit ramp cleared so that we don't introduce any safety issues onto the motorway. That's another type of application. You can also think about stadiums. If there's a left-hand turn out of a stadium, you can just as easily put that there as well. And that's one of the beauties of having SynchroGreen be a part of our ATCS package, because it isn't operating in isolation. It's operating, again, my favorite word, in conjunction with all those different tools that you have out there. So you can use those triggers or stimulus points to then have SynchroGreen take certain actions to mitigate concerns that you see arise in the network. And that's because it's part of that overarching ATCS application set. Additional optimization features, we've hinted at a few of these so far, but preemption functionality is maintained. So again, TSP, compatible with TSP, that's a very common application that we see. No transitions due to the cycle or offset changes. So again, addressing one of the questions that was just asked. Pedestrian strategies are included and factored into the base analysis. You have dynamic critical intersection selection, multi-serve capabilities depending on what's happening out there. You're able to maintain intersection-specific functions. So those flashing yellow arrows, because they are a controller level activity, and SynchroGreen is a software package that works on the traffic controller, you're able to maintain that functionality. You have a complete audit log for all the decisions that are done. So if you need evidentiary reports for traffic tickets, things of that nature, you have a complete audit log for what's been called every single time out. And then there's a comprehensive library of management reports, including Purdue data reports. And now we'll quickly step through this analyzing outcomes section. So the first way for analyzing outcomes that we'll mention is using Bluetooth readers for travel time. In this example, you're able to see what the travel time was before. So we did some before analysis using the Bluetooth devices. And then you're also able to see what the travel time is after SynchroGreen was deployed. So if you took advantage of the modeling service that is available if you are an existing Synchro Suite user, you can then look at the projected results that the modeling said, and you can see what exactly happened out there. So if you were using the modeling for the before analysis, because the Bluetooth wasn't deployed in time, you can then take that and then say, okay, and this is what we said we were going to get, this is what we did actually get. Now, one thing to note regarding these travel time decreases and the benefits associated with it. If you're ever in a conversation with someone and you're talking about adaptive, and so they say that, you know what, no matter what corridor you put us on, we're going to give you a 40% increase or decrease in travel time, no matter what. I would say run as quickly as you can in the opposite direction. Why is that? Well, the travel time decreases that you see will vary depending on the existing conditions. If this is a corridor that has not been retimed in over 10 years, if this is a corridor that has no existing instrumentation, if it doesn't even have traffic controllers, and you suddenly put out adaptive, you're going to see some very significant improvement, that 50, 60, whatever percent range in terms of what the travel times are today versus what it is now that you've deployed adaptive. And you're going to have everybody knocking on your door trying to write a case study. However, if you're talking about a corridor that is one of your problem corridors, you've thrown your best and your brightest at it, you've put new technology out there on the detection side, you've tweaked the time of day plans twice a year, even more than that, and you're still not able to get the type of results that you want to see. If you then put SynchroGreen on that corridor and you see a 5% improvement, that's an awesome outcome. But if I went into it and I said, you know what, you're going to get 40%, I then did you a disservice and I did the technology a disservice. And that's not the business that we're in. We want to set realistic expectations so that everybody walks into it eyes wide open and they're able to say, okay, given what's currently out there, this is what we should expect. This is what we can reasonably expect. And we're confident that SynchroGreen is going to do it. But if I tell you 40% every time, it's just going to set up everybody for some hurt feelings. And it's going to put what objectively could be considered good results in a negative light. And that's not what we want to do. We have one more slide, and then we'll just address those couple of questions. If you were presenting to management on the results that the SynchroGreen system is delivering, and you had the choice of two reports, I would say choose the travel time report as opposed to this particular Purdue data report, which is green utilization, because intuitively it's a lot easier to understand travel times went down than it is to work through this green utilization report. But basically what it's saying is that the more dots that you see within the green, the better. And you're able to look at over time how the results have been trending and confirm that more folks are arriving on green, which means that you're getting better progression through your network. And with that, we've made a mad dash to the finish, and I'll now open it up for the remaining questions.
Well, thank you, Matt, and thank you all for attending. We do know that we only left about a 2-minute window for questions, so to be respectful of everyone's time, if you need to hop off, please do. We will keep it going for a few minutes after if there are more questions. We do have a couple from Don McGowan. Matt, he said, if there's detection failure due to SIU failure or communication, where is best setting? Do we fall back to time of day?
So if detection drops out, SynchroGreen has the ability to look at the adjacent lane for information and then use that instead. It also has the ability to look at historical data that can be set in the settings. So if you are in a particular area that is more prone to communications or detection dropouts than others, you can have that configured that way. Otherwise, eventually you can also have it fall back to time of day. But for detection, we're usually looking at adjacent ones as opposed to just falling back.
Perfect. All righty, any other questions? While we're waiting, please feel free to continue typing your questions in the Q&A. I did want to remind you guys that we will be sending all attendees a post-webinar email with links to helpful resources about SynchroGreen and the link to this recorded presentation. We will keep this going for about 1 more minute. Please type your questions in the Q&A. As a wrap up, we do have a webinar Wednesday, next Wednesday, April 29th at 1 p.m. Eastern Standard Time, where we will be discussing the Synchro 11 features. Please consider joining us next Wednesday for Webinar Wednesday as well. Matt, it doesn't look like we have any additional questions. So thank you everyone for your time. Please contact Matt Cooper directly. His email address is up for you if you have additional questions. Thank you all so much.
Thanks, everybody. Appreciate your time.